Hello everyone, welcome to Math Elevate. Today we'll see properties of parabola. First property, tangents drawn at extremities of focal chord intersect at the directrix. This property is quite easy to prove. We know that point of intersection of tangents is A T1 T2, A T1 plus T2. For a focal chord T1 T2 equal to -1, so minus a comma a t1 plus t2. As the x coordinate is minus a, it lies on the directrix. Also t1 t2 equal to -1, slope of tangent is 1 upon t, so 1 upon t1 into 1 upon t2 equal to -1, so m1 m2 equal to -1. So these tangents are perpendicular. Also the director circle of a parabola is the directrix itself. Second property, a circle drawn taking focal chord as diameter touches the directrix. This property is not to be confused with, if we draw a circle with focal radius as diameter, it touches the tangent at vertex. So focal radius as diameter, it touches tangent at vertex, and focal chord as diameter, it touches the directrix. Third property, if a tangent at P intersects directrix at Q, PQ will subtend 90 degree at focus. So this property is quite easy to prove. Let P a t square comma 2at, the equation of tangent is ty equal to x plus at square. As it intersects the directrix at Q, so the x coordinate of Q is minus a, find the y coordinate. Now the slope of SQ, find the slope of SQ, find the slope of PS. As the multiplication of both the slopes is -1, so we can say that they are perpendicular. Fourth property, if tangent at P intersects the axis at Q, then tangent at vertex bisects PQ. This property is also quite easy to prove. Find the coordinates of P, find the coordinates of Q by putting y equal to 0, and the coordinates of midpoint are x1 plus x2 by 2, y1 plus y2 by 2. Also, these properties are valid for all kinds of parabolas. We are just proving for y square equal to 4ax. Fifth property, tangent at P is internal angular bisector of angle SPM. So SPM, where M is the foot of perpendicular from P to at the directrix. So this angle and this angle are equal. Next property, normal is the external angular bisector of SPM. So SPM, we will extend P and M, and this is the tangent, this is the normal, so this angle is equal to this angle. Now due to this property, we have the reflection property. So any ray parallel to the axis which in after reflection passes through focus, as this is the angle of incidence from the normal, and this is the angle of reflection, and angle of incidence equal to angle of reflection. So ray parallel to axis passes through focus after reflection. Next property, tangent at one extremity of focal chord is normal at other. This property is quite obvious, as t1 t2 equal to -1, slope of tangent is 1 upon t, and slope of normal is minus t, so both are equal. Next property, tangent and normal at extremities of LR form a square. This property is also quite easy to prove. Next property, foot of perpendicular from focus on any tangent lies on tangent at vertex. So this is the focus and foot of perpendicular from any tangent. So to prove it, just write the equation of tangent ty equal to x plus at square, and the formula for foot of perpendicular is x minus x1 by a equal to y minus y1 by b equal to minus, just put that point on the line, upon a square plus b square. So these two get cancelled and x equal to 0, which is the y-axis and tangent at vertex for our standard parabola. We already discussed next property, focal radius as diameter, that circle touches tangent at vertex, and focal chord as diameter, it touches the directrix, as we discussed. So next property, if normal at P intersects the circle with PS as diameter, so PS is focal radius. So normal at P intersects circle with PS as diameter at N. So Pn is A under root 1 plus T square. Quite direct questions are asked from this property, so it is important. Next property, if tangents at points P and Q on the parabola intersect at T, then TP and TQ will subtend equal angle at the focus. So we can prove this by tan theta equal to m1 minus m2 upon 1 plus m1 m2. So this angle is equal to this angle. Next property, if A, B and C are 3 points on a parabola and tangents at ABC form a triangle PQR, then area of triangle ABC equal to 2 times area of triangle PQR. So A, B and C, this is tangent at A, tangent at C, and tangent at B is the tangent at vertex because we are taking B as vertex. So PQR, and area of PQR is half that of ABC. Next property, in triangle PQR, here triangle PQR is this same triangle whose sides are tangents. Then the coordinates of orthocenter are minus A product of T1, that is T1, T2, T3, plus A summation of T1, that is T1 plus T2 plus T3. So as the x coordinate is minus A, the orthocenter lies on the directrix. Circle of triangle PQR, again this same triangle PQR, the circumcircle passes through the focus. Point of intersection of tangents, as we discussed, A T1 T2, A T1 plus T2. To remember this, we can remember first the x coordinate is the GM of both coordinates. So A T1 square into A T2 square under root, that is A T1 T2, and the y coordinate is the arithmetic mean of both the coordinates, y coordinates, that is 2A T1 plus 2A T2 by 2. So A T1 plus T2. So GM AM. Next, tangents at P and R intersect at Q. So P, R and Q, as we discussed. P1, P2, P3 are the lengths of perpendicular from PQR or any tangent, then P1, P2, P3 are in GP. So to prove this, just write tangents equation, and the formula for perpendicular distance is put the point on the line. So A T1 square minus 2A T1 plus AT square. We just put A T1 square comma 2A T1 in this line upon under root A square plus B square. So in this case T square plus 1 square, T square plus 1 under root. So like that we can find P1, P2 and P3. So we'll get P1, P3 equal to P2 square. So P1, P2, P3 are in GP. Now for the next properties, length of subnormal equal to semilatus rectum. You can just remember length of subnormal is modulus of y dy by dx. Length of subtangent is y dx by dy. Obviously the modulus. Length of tangent is y under root 1 plus dx by dy whole square, and the length of subnormal is y under root 1 plus dy by dx whole square. Next property, PMTS is a rhombus. So P is a point on parabola, S is the focus, M is the foot of perpendicular on directrix, and T is the point where the tangent at P intersects the axis of parabola, here x-axis. So PMTS is a rhombus. So length of normal chord 4a t square plus 1 power 3 by 2 upon t square. You can derive this by using distance formula t1 and minus t1 minus 2 by t1 as here. So next property which we just discussed, the normal at P, that is t1, meets the parabola at t2. So t2 equal to minus t1 minus 2 by t1. t1 T2. Remember the order. T2 is where it meets the parabola and T1 is the point at which the normal is there. Next property. There are 2 points on the parabola T1 and T2. The normals at T1 and T2 meet at a point on the parabola T3. So T1 T2 equal to 2, T1 T2 T3 equal to 0. We can prove this. So T1 T2 T3, T3 equal to minus T minus 2 by T, minus T3 equal to T plus 2 by T. So minus T3 equal to T square plus 2. So T square plus T into T3 plus 2 equal to 0. So the roots are T1 and T2 because T3 equal to minus T1 minus 2 by T1 as well as minus T2 minus 2 by T2. So sum of roots T1 plus T2 equal to minus T3 and product of roots T1 T2 equal to 2. So T1 T2 equal to 2, T1 plus T2 plus T3 equal to 0. Yeah, we have the same result. Next property, condition for 3 real normals at a point h comma k. This is necessary as well as sufficient condition. 27 ak square less than 4 h minus 2a whole cube. Next property, ABC are 3 conormal points at P. So SA, SB, SC equal to ASP square. Next property, area of triangle formed by chord of contacts and pair of tangents. Pair of tangents is SS1 equal to T square. So this is pair of tangents and this is chord of contact. So S1 power 3 by 2 upon 2a, and for S1 just replace in the equation of the conic, just replace x by x1 and y by y1. Next property, if a chord joining T1 T2 passes through a fixed point C, 0 on axis, then T1 T2 equal to minus C by A. So in this property, if we replace C by A, that is focal chord, we get T1 T2 equal to minus 1. Length of focal chord, if it makes an angle alpha with the axis, it is 4a cos x square alpha. So this is